so we're turning our test. Time's up. Time is up. Hopefully that wasn't too bad and you all survived. You need two things right now. You need page 2 of the packet, which isn't numbered, so it's just the second page. And you need your green sheet. The green sheet has a bunch of identities on it, not all of which we're going to be using right now at this moment. We'll pick these up as we go. But some of them are ones that you need to have memorized. So I have on your old homework sheet, your purple sheet, it says down there at the bottom or somewhere on there, it tells you to go to certain pages and memorize green boxes. Doesn't it? Maybe the boxes aren't green, I don't know what color they are. What page are those on? 445. Here we are. Yeah, they are green. Okay, so 445 and 447. So the things you're memorizing are the reciprocal identities and the quotient identities. Now, what about the reciprocal identities? Don't you already have those memorized? Well, yeah, because what's the cosecant? The reciprocal of the sine. So cosecant is 1 over sine. Don't make that harder than it is. You already have that memorized. Now, one especially, very useful identity is the tangent identity in terms of sine over cosine. Those are called quotient identities, but it's sine over cosine. That makes sense to you because you know that sine is y over r. You've already memorized that. You know that cosine is x over r. And you know that tangent is y over x, right? Well, if you put this over this, if you put sine over cosine, look what happens. If you put sine over cosine, you have y over r divided by x over r, which is y over r times r over x, which just reduces to y over x. So sine over cosine is a really useful thing to remember. Tangent is sine over cosine. So that's that green box. That's pretty easy. Now next green box is huge. It is the Pythagorean identities, and they're simple, but they are so very important. I'm going to draw a little triangle here. I'm going to call that x, that y, this r, and that theta. Now, is there anything there that bothers you? Does it make sense to you that this would be x, this would be y, and if you envision a circle, I can call that r, and of course my angle is always the one at the origin, right? Now, you know that x squared plus y squared equals r squared. That's absolutely true. If I were to divide everything by r squared, I would have x over r squared plus y over r squared equal to 1. What's x over r? Cosine. So this is cosine squared, and that is sine squared equal to 1. Always, always, always. Sine squared plus cosine squared is 1. Now, the other Pythagorean identities are versions of that one. So if I know sine squared plus cosine squared is 1, which I know, that one is so important, it's called the fundamental trigonometric identity. There are millions of trigonometric identities. This one's called the fundamental one. This is the biggie. If you were to take it and divide everything by sine squared, you would get another one of the identities on the sheet. This is 1. All right, now what's this? Look back at your quotient identities. What's cosine over sine? Cotangent. So this would be cotangent squared. What's 1 over sine? Cosecant. So there's another one of the Pythagorean identities that's written on the page, but it is just a version of this one. How do you think we get the third one? Instead of dividing by sine squared, divide by cosine squared, and it will give you 1 plus tangent squared is secant squared. Okay? Throughout math, and you're going to discover this when you take your calculus class, cotangent and cosecant are linked, and tangent and secant are linked. And the linkage is all because of this identity, these identities. Alright, so those are the Pythagorean, very important. The cofunction identities. Now, I've kind of talked about the cos a little bit when I said the cos are never paired up with each other. So cosecant goes with sine, and secant goes with cosine, and so on. But what does it mean? Why do we have 3 main functions and then these things called cofunctions? Why do we have those? Well, I'd like you to think about something, and you may have already observed this. I don't think we've ever talked about it, but you may have observed it. Let's say we've got, let's just go back to this situation. Can you tell me how big that angle would be right there? How big would that angle be? Can you tell me? Well, what if this were 50? Could you tell me how big that one was? How big would that one be? 40. How'd you get 40? 90 minus 50. So what if this were theta? 90 minus theta. Don't we know for sure these two are going to add up to 90? They're what we call complementary angles. Complementary angles. Remember what the word complementary starts with, the 2 letters it starts with. Complementary angles. All right, let's look at this for a minute. What would you tell me the sine of theta is? Y over r. What would you tell me the cosine of 90 minus theta is? Well, look at this angle. What would the cosine of 90 minus theta be? Y over r. Oh my goodness, what do you notice? The sine of an angle is equal to the cosine of its complement. The sine of 50 is the same as the cosine of 40. Guess what? The tangent of 50 is the same as the cotangent of 40. The cofunctions mean that their values match on complementary angles. So the sine of 10 would be equal to the cosine of 80. That's what it means to be a cofunction, complementary functions. Okay? So when you see something like, okay, what does the tangent of 90 minus theta equal? As soon as you see that 90 minus theta, you're thinking complementary. What's the complementary function for tangent? Cotangent. The cofunction, complementary function. So if I said what's sine theta equal to, you could say it's the cosine of what? The sine of theta is equal to the cosine of 90 minus theta. Indeed. So that's what it means to be complementary. When you see that 90 minus theta, you're thinking complementary angles, cofunctions. And you can't miss tan, cotan, secant, cosecant. Not reciprocal functions. That's a whole different thing. These are the cofunctions. 90 minus theta. When you see that, you're thinking immediately cofunction. Okay? So if somebody says cosecant, 90 minus theta, you see that, you think, oh, cofunction. Cofunction for cosecant is secant. And then the last grouping that I asked you to memorize are the even odds. We know what even and odd means. Can somebody tell me? In terms of the graphs, we studied it back a long time ago. what's it mean to be even or odd? Does anyone remember? Okay, it has to do with symmetry. And yes, what you just said, Wyatt, is true. You gotta be careful though, because it's not uniformly true. So if something starts down and ends up, it's not automatically odd. But if you're odd, you could have that behavior. Even means you're symmetric about the y-axis. Odd means you're symmetric about the origin. Now, when we look at our cosine curve, the cosine is clearly even because it has symmetry about the y-axis. So in terms of an equation, what it means to be even, and I know we've talked about this, but you probably forgot this part. If you're even, then if you plug in a negative value for x, it doesn't have any impact. So in other words, if you found the cosine of 30, it would be exactly the same as the cosine of negative 30. When the negative has no impact, you are an even function. There are only two that are even. The cosine and, you want to guess what the other one is? It's reciprocal. The cosine and the secant are even functions. So what it means to be even is you just ignore the negative. The negative goes away. So if you are doing a trigonometric proof, and that's where we're headed, and you run into something like this, you can immediately change it to this, because cosine is even and inputting a negative has no impact. All of the rest of the functions, tangent, cotangent, sine, and cosecant, are odd functions. Okay? Now what that means is, if you put in a negative, you get out a negative. If you are odd, it means input a negative, output a negative. That is true for all of the odd functions. And everything is odd except secant and cosecant, or secant and cosine. Okay? So, with all that floating around your head and you're thinking, oh my gosh, she's making me memorize so much. Yes, I am. There's no way around it. Let's look at this page 2, a couple of old quizzes. In fact, there's one on the back too, so we're getting some good practice here. Let's see if we can plug in the blanks. All right, so when we're plugging in a negative x, everybody's looking at page 2 of your white packet for chapter 5. Not the back of page 1, honey. No. Those are monster problems you were just looking at. All right, so we're on the second full page. And I didn't number them. It says memorization quiz at the top. What goes in the first blank? Negative tangent. Negative tangent. Why? Because the tangent is odd. And when I input a negative, I output a negative. Negative tangent x. Negative tangent x. All right, number 2. See the 90 minus? What does that click in? This is a complementary. This is a What's the co-function for cosine? So you write sine theta, or sine x, I'm sorry, sine x. You write sine x. When you've got squares, like you do in number 3, you're thinking Pythagorean. Those are the Pythagorean identities. 1 plus what is secant squared? Look at your green sheet, look at your book. 1 plus what is secant squared? 1 plus tangent squared x. So you write tangent squared x. And I can't remember if we talked about this or not, but when we square a trigonometric function, we always put the square there. Now that means the same as this, but we never want to write it this way. Does everybody understand why we wouldn't want to write it that way? because we're not taking the tangent of x squared. We're squaring the tangent. So that's why we write it this way. But it means the same as this. This is wrong. 1 over tangent. What is the reciprocal of the tangent? 1 over means reciprocal. Cotangent. X. Make sure you put the X on there. Sine X over cosine X. This is one you are going to use probably every day. Tangent X. That's tangent X. Alright, next quiz down. Cosine negative X. Okay, this is your even odd. This is your even odd. What's cosine negative X? Cosine X. Because cosine is even and the negative disappears. Tangent 90 minus X. That's your cotangent X. Because you see the 90 minus and what immediately pops into your head? Complementary co. Number 3. 1 plus tangent squared is secant squared. So you write secant squared X. You write SEC squared X. Secant squared X. 1 over secant. That's reciprocal. What's the reciprocal of the secant? Cosine. That one you already know, or at least you should. Cosine over sine. Cotangent X. Cosine over sine, that's one of your quotient identities. Cosine over sine is cotangent X. Backside. We can't do the ones at the bottom yet, but we can do the ones at the top. So, sine negative X. Alright, this is even odd and putting a negative. The answer will be negative sine X. Remember, they're all going to end up negative except for cosine and secant. All the rest of them are going to end up negative. So this is going to be negative sine X. Alright, number 2. Cosine X. Now, did you do that without looking at your green sheet? Yes, hopefully, because you saw 90 minus. You said, oh, complementary. The co-function, complementary function for sine is cosine, so cosine X. 1 plus what is cosecant squared? Cotangent squared. 1 plus cotangent squared is cosecant squared. 1 over sine, cosecant X. Cosecant X. And cosine over sine is cotangent X. Next time we have class, which is what, Tuesday? Yes, what you're going to get to do. You're going to get to have a quiz, and the quiz is going to look just like it. Whoa, you're not done, you're not done, you're not done. Don't wrap up. No, you're not done. But we're done going over that, because now your job is you memorize those. Mrs. Ford is not saying memorize the entire green sheet, although you're welcome to do that. You must memorize the 4 categories that I have given you, which are on the green sheet. I think they're the first ones, aren't they? They're the quotient identities, the reciprocal identities, oh no, there's 5 groupings, I guess. We gotta have everything down to section 5.3 memorized. Okay? And you already have some of that. Good. On the sheet, I got the sheet from Mr. Thompson. In the co-function identities, he's got pi over 2. Feel free to replace that with 90. Yeah. Pi over 2, that's fine. Feel free to replace that with 90. Now, I'm going to do a little bit of your homework for you. Open up your book to page 451. And you might as well get out a piece of paper. I'm going to do a few of these for you. Alright, so we're going to do one from the quick review because I assigned some of the factoring problems in the quick review, so I'll just do the first one. But I want you to leave room for 6, 7, and 8 before you start the next one, because I want all those quick reviews together. But number 5, quick review, says factor. Now you're thinking, what the heck are we factoring for? Well, in this chapter, we're going to be factoring and solving, factoring and simplifying trigonometric expressions. So instead of A's and B's, we're going to have sines and tangents and things. So the author of the book thought it would be a good idea if we practiced a few regular problems before we jump in and do the ones that trigger. So this is a quick review for section 5.1. And how does that factor? Can anybody tell me how this factors? It's a trinomial, so I'm thinking a couple parentheses. What do you think? How does that factor? A in the front, for sure. A squared. What has to be in the back? B's, because we got b squared. Now I need a minus 2ab in the middle, so I guess these have to be minuses. Would that do it for me? Is that factored okay? Yep, and you're going to do 6, 7, and 8 on your own. Now we're going to look at a couple that are that use the trigonometry. So number 9 says simplify tan x cosine x. We're going to simplify this. Remember the identity I told you you'd probably use every single day? Were you listening when I said that? That was your quotient identity that says tangent is the same as what? Sine over cosine. So I'm going to replace this with sine over cosine. And what happens? They cancel. And when it said simplify, it simplifies down to just sine. That's the kind of work we're going to be doing. The problems are going to get a little harder than that. Let's try the next one. Cotangent, tangent. Is it cotangent? Yeah, cotangent, tangent. Now your job is to simplify that. So how do you think you might do that? Okay, you can do exactly what we just did, only you got to change both of them. So this would be cosine over sine, and this would be sine over cosine. Whoa, 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 what happens? It simplifies all the way down to 1. Does that make sense to you? What's the relationship between the cotangent and the tangents? They're reciprocals. And what happens when you multiply reciprocals? You get 1, right? They cancel each other out. Oh Lord, look at this next one. How hard does this look? I'm going to change that pi over 2 into a 90. So I have secant y times sine 90 minus y. Tell me about that. That's a complementary function, right? Complementary identity. It's sine. What is the complementary function for sine? What is the co-function for sine? Cosine. So this is the same as cosine y. Remember, when you do the complementaries, one of them is 90 minus y and the other one is just y. That's what complementary angles are. So now I have secant times cosine. Secant and cosine are reciprocals. What's going to happen when you multiply them? You're going to get 1. Now, if that's too much for you to process, we are just getting started with this after all. Remember, secant's 1 over cosine, right? So when you multiply these two together, they are going to cancel and you are going to get 1. You don't have to show this work. Anytime you multiply reciprocals, you're going to get 1. now we've got cotan sine. All right, what do you think about this? Cotan sine. Okay, let's quit watching the clock. I'm doing your homework for you, for Pete's sake. Be happy. Cotangent times sine. All right, what's your thought? You got to simplify this. Change cotangent into cosine over sine. Answer is cosine. All right, you guys are getting the hang of it. Awesome. Oh my, look at the next one. 1 plus tangent squared over cosecant squared. All right, now, I happen to love trigonometric identities. This is one of my favorite parts of the year. Killed me last year when I was sick and missed this. But here we go. I love it, love it, love it. And I've been doing it for so long that when I write something like this down, 1 plus tangent squared, little bells go off in my head. Ding, 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 ding. Because 1 plus tangent squared is on my green sheet. You got to get to the point where you recognize that. I don't expect that today or tomorrow or the next day, but in a week, that should be making bells go off in your head. 1 plus tangent squared is secant squared. So I've got secant squared over cosecant squared. All right, now, tell me about secant squared. What is secant squared? It is the reciprocal of cosine. So I'm going to think of this as 1 over cosine squared. And then what about cosecant squared? It's 1 over sine squared. I know what you're thinking. You're thinking this is looking worse, not better, Mrs. Ford. But think about this now. 1 over cosine squared times sine squared over 1. Because when I divide by 1 over sine squared, it's like multiplying by sine squared over 1, right? And so when I multiply those, I get sine squared over cosine squared. Ding, 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 ding. Sine over cosine is tangent. So that mess simplified down to tangent squared. Pretty cool. All right, well, I got that started for you. You're welcome to go ahead and try a few more of those. It's going to be hard in the beginning, but not the memorization. That's easy. Get that done. You can do that. Okay? Over there in the top right.